Hi, this is Fred, and I'm going to be doing project number 1. Now, it says to upload data into database and determine the number of counts for numbers found N1 through N6. This would be referring to lottery numbers that we have previously entered into the database. So I will go ahead and take us over to the database right here. And as you can see, we have a database named lot. From Postgres, and we can go here to schemas, choose lot schema, and over down here we have lot 1, lot 2, and I made another one called frequency for organizational purposes. And we have, if we view data, we can see that it's recorded the integer of the entry type and the specific number that was chosen for that person's lottery number. And we're going to take a look at what the distributions are for which numbers get selected most frequently. So to do that, we're going to go over to our SQL editor here, and I'm going to show you a few summaries of the different categories for selecting the first number, the second number, the third number, on and on until 6. So as you can see, I'm going to be selecting the column N1 from lot and lot N2, and then group it by N1 in ascending order. The count here is going to show us how frequently the number 6 is chosen in the entire first number category. So let's see what that looks like. So as you can see here, it's in ascending order, so the number 1 showed up 40 times in N1. The number 2 showed up 55 times, so on and so forth, all the way down to here. Now, you can choose numbers up to 75, but 43 is the highest number chosen for the first integer, or for the first column. Now, we can go on to the next one here. I've commented them out so that they don't interfere with the previous code. Now we can see the data for N2. You can see it's the same thing, but for the second column, it's just showing us the different number of frequencies that the second number has shown up. You can see if the top number is 64, which has occurred once in this one. Now we go on to N3. Go ahead and run that, and that shows us the distribution here. See, numbers 1, 2, and 3 don't show up here. So if we tried to run an aggregate solution through this same method, it would mess it up because there was no numbers 1, 2, and 3 to count by. So we continue doing that for N4 through 6. I'm just going to go ahead and uncomment all of them because it's the same data that you see on the left, just counted up differently. So you get an idea of the distribution. Now we have our 6th category here, which shows a pretty even distribution, coming more and more selections into the higher number range. Now we come over here to project, and we see that the next we've determined the number of counts for each numbers found N1 through N6. Now we're supposed to create a histogram which determines the distributions found in N1 through N6. Now to do that, we use MATLAB. So come over here to our MATLAB function. We come up here to the top, and we can see that I'm establishing a connection to the Postgres database by this code here, which let me show you a little bit more of that, if I can. Yeah, and it's got all my information for which schema, which database, which table to select all the data from, and then it fetches the data and turns it into a matrix that I can use in data manipulating here in MATLAB. And then I create a table which will then store a histogram of that data, and if we run it real quick, see we have 6 different graphs which show us the distributions. Now, for N1, which is the first number, you see there's a much higher frequency for lower numbers than higher numbers. It almost looks like an exponential distribution, because one of the reasons that might be is because the lower numbers are more typically, more frequently chosen in the lottery selection. Now we can go on to figure number 2, which is N2, and you can see the mean moves over a little bit, more towards the higher medium range numbers. We go over to N3, you see it's even more so. People must think in sort of a linear fashion, since they've chosen the lower numbers first, then the high, then medium, then a little bit closer to the medium, and then N4, you can see that it looks like almost a normal distribution, because it's got most of the frequency hitting out 40. They could only choose numbers 1 through 75, so that's right about at the middle. So then we go over to N5, and you see that it comes over here more towards the higher numbers. And then lastly, N6, you can see it's just kind of an even spread all around, because people figure it's the last number. They usually choose something that's either significant to them, or they just try and balance out what they've already chosen in the previous selections. So you can see that distribution kind of is just all over the place. Now, in the next part of it, it asks us to determine the number of counts for an entire list of numbers. Now, for the easiest way to do that was to change our input data and make a different table, which I will show you here. We go over to lot in 1, and we view the data here. Okay, this table doesn't have a primary key, but I just took all the data from N1 through N6 and made it into one giant column here, as you can see. And then I basically did the same sort of code that I showed you previously. The only difference is I did it for this one, which then shows us the entire distribution in one summation. So 61, 71, all of them are very high, because it's showing us the selections for all of them across the board. Numbers 1 through 75. As you can see, the only numbers that really don't have very high number of frequent selections are those numbers 57 and up to 75. Maybe people don't feel as comfortable choosing the higher numbers because they feel like they are selected less, but we really don't know. So we have this data, and now we can go back over to MATLAB and show the histogram of that. I have a different script file for this. It's the same code as before. The only difference is I chose a different column histogram and a different table in my selection. And it comes up here. Boom. Now, so you can see, just like the data showed, it was a high frequency from pretty much all of them, slowly decaying down and then dropping off sharply as we get into 60 and above. Now that should be everything in Project 1. The only thing we can really determine from that is people seem to think that lower numbers have a higher chance of winning than the higher numbers.